Welcome. My name is Jamika Marshall, and I serve as the Shadow the Scientist Coordinator. Shadow the Scientist is an initiative housed under the Creating Equity in STEAM umbrella of programs offered by a team at the University of California, Santa Cruz. In this session, we have the privilege of shadowing Dr. James J.D. Armstrong, the Maui Technology, Education, and Outreach Specialist at the University of Hawaii's Institute for Astronomy. He manages UH's time on the 2-meter Falks Telescope North, located on Haleakala in Maui, which is owned and operated by Las Cumbres Observatory Global Telescope Network. JD's work includes research on exoplanets, asteroids, comets, stellar objects, and double stars. Now, in our previous shadow session with JD, he shared how he performs follow-up observations of near-Earth object candidates. During a recent such follow-up with Las Cumbres Observatory of Robotic Telescopes, he detected an unknown object. This could be a new asteroid discovery. In today's session, JD will give a live update on this potential find. Now, this session is being streamed for those in attendance at the City of STEM and Makers Fair in Los Angeles. My colleagues Anand Lalria and Lindsay Laver are there in person at this wonderful event and are sharing this live stream there at the booth. Anand and Lindsay, if anyone has questions, please feel free to drop them in the chat at any time, and JD will be sure to get to them when he has a chance. All right, without further ado, JD Armstrong. Welcome, JD.
Thank you. Welcome, or I guess thank you for the welcome. There we go. Wonderful to see you. I hope everyone enjoys this. I'm going to try and get one more program up. It's hiding on me. There we go. I'm going to bring this up here, and then I'll go ahead and share my screen because I think that what I share on my screen will probably be much more interesting. At least I hope it will. So I thought we would start off by looking at the observations that I was looking at originally. Now, the original observations, I guess. And they are right here. So this is a program called Astrometrica. And what Astrometrica does is it looks at all the stars in the image and it creates a map, a very careful map of where each pixel is in the sky. And the idea is that we take 4 images of the same part of the sky and look for things that move. Those are our asteroids. And I've already measured these images, but I just wanted to go back and just sort of double check them. So we'll go through this. These observations, I was following up on a target that was discovered by the Atlas Observatory, and it showed up on the Minor Planet Center near-Earth asteroid confirmation list. And so those are objects that they're hoping someone will do some follow-up. Hopefully this will register this time. Sometimes Astrometrica has a little trouble recognizing all the stars in the field. That's what's happening now. It's not uncommon. Give it one more shot. I might have another trick that I can pull if it doesn't register this time. And so anyway, the Minor Planet Center, when Atlas sees an asteroid in their field of view, they measure its position and just send it off to the Minor Planet Center. And the Minor Planet Center does all of the sorting on this. I'm just going to change the configuration here. Okay, yeah, that works. Okay. I think that might be a little bit of a difference. There we go. And everyone cross your fingers or whatever. Yeah. Hopefully it'll register properly this time. If not, we'll just look at the blinking images. So basically, so the Minor Planet Center goes through and keeps track of, a few million objects. I'm just going to pretend that that worked because I've already got the measurements. I already got it to register. I'm not sure what the difference is this time, but. And so we come in here. So the Minor Planet Center takes all these, sets of 3 or 4 measurements, maybe sometimes more, but usually like 3 or 4. And they go through with a computer, obviously, and add all the measurements that they receive to the record for each asteroid that is known. And then occasionally they find someone comes across something that's unknown. And then the first thing they do is they check to see if it's possibly a near Earth object. And so we'll just go in here real quick and see if we can't find our moving objects. So an asteroid is going to look like a star, maybe like this guy, but it will move in the images. And right there's a good example. So this is one of the objects that I detected and measured. Okay, I'm not going to do that because I have no confidence in the registration, not even enough confidence to go ahead and check it. But so when I was looking at this object, so I got these were the measurements of that target that I took. But there was this other object in there that I didn't know what it was. And so the first thing you do at that point is you go ask the Minor Planet Center, hey, do you guys know what this is? And so we go to the Minor Planet Center, and you only have to give it one line of the observations, if we can get there. Let's just put that on hold. I'll let you know when that comes up. Fingers crossed again. But there we go. So this object, I put it into the other services. There's this Minor Planet Checker, and basically this says, hey, here's an observation. I'm seeing something here. Do you know what it is? And so we go ahead and click on Produce List. This will take a moment because they're checking it against millions of objects. Basically, it came back the other day that no, they didn't know what this was. So I immediately turned around and requested some more observations. Okay. The original detection was on one of Las Cumbres' telescopes in South Africa, which is a pretty good site. I'm usually pretty happy when I get data from there. And then a few hours later, it was easier to observe that over in Chile, in Cerro Tololo. Okay, so this is saying, well, the closest object I know about is something that is over here. It's off a little bit in the west and a little bit to the south. So it might be that that's the object, but they're saying, hey, we know where this object is. And so I kind of don't think that is it. And if I recall, there was another nearby asteroid that I said, okay, that's probably the one. Let me see here. Hold on for a second. So, yeah, I think that this was another, I'm going to put another line in here and do this. Check this one, because there were two objects in the image that was not the one I thought I was chasing. Oh, actually, wait a minute. Oh, that's the same as the previous one. Okay, so then I went ahead and I used these observations to predict where it was going to be. And that's also another Minor Planet Center thing that they will help you do. So observations, let me see here. So the first thing you do is you want to go and you want to say, hey, is this a potentially hazardous object or a near Earth object? So I took the observations, copied those over here. This is the NEO rating page of the Minor Planet Center. Put them in here. I want to know all orbital classes. So this will evaluate what's the probability based on this very small amount of information. What's the probability that this might be a near-Earth object? And NEO rating, what is that, 6? So like maybe 6%. I'm not quite sure if that's the interpretation, but it's 100 is, yeah, this is pretty much an NEO. 0 means no, pretty sure it's not an NEO. It looks like this is most likely a main belt object. So that's what we would do, what we would be looking at. So then I did get these other observations from Sarah Tololo. Let's go ahead and look at those. And let me go ahead and close those. And the prediction at that point, oh, I was going to show you how we predict that. So in addition to this rating, then you can also come down to, whoop, it's a little tricky to navigate on this bit. Okay, there we go. New object ephemeриdes. Pardon me. So you can take these observations, drop them in here, and generate new coordinates. Okay. And so I did that, and then I went ahead and observed the new field, which was pretty close to the old field because it was pretty soon afterwards. And here are the images we got. Let's see if these will register properly. And as I mentioned, these are from from Chile, from South America, from Las Cumbres, and you can tell that by LSC is their code for South America. Okay, come on. But the newest images, I have it set up so that it should register okay, because I checked those last night. The next step would be I would go into the manual mode, which basically puts up a screen here, and I can click on some buttons to move it around. But the problem is, if I go into manual mode, it doesn't work if I've got two screens. It just fails. So I'm going to cancel that. Oh, I might know what's wrong here. Yeah, let's change to that configuration. That's probably the problem. Let's just do one image. It'll be quicker. And if one image registers, then we're good. We'll open up the others. And apparently it's not. So let's just go on to the next images. But I did detect it in these three new images. The problem was that there were two objects this time. Okay, so we go over to the minor planet center, and two objects that I wasn't sure about, so we check on those. And except for we don't put them in our put them in MP checker. That's where we're going. Produce list. And then where we're going to be in excitement for today is I use those observations to predict where the object was going to be a couple of days ago, about 3 days ago, and got some observations. And I've been over at a conference, and so I have not had the time really to look at this very carefully. I just basically was able to download the images last night was when I finally was able to download them. And so I'm going to look at those, and we're going to keep our fingers crossed that maybe this is a new object. Okay, so I'm going to put these up here. And let's see, I want the other configuration because I did get this registering last night. We'll see if it goes ahead and makes me look foolish. It does tend to like to do that. So there we go. Okay. And so that's this. I just opened up a configuration file that is specific for this telescope. We have to tell the telescopes which way the camera is oriented on the sky, and also a little bit of information about the scale of the image. Doesn't know that off the top of its head. It has to be given that information. There's nothing you can really measure in the image that will tell you that. There we go. This is what it should look like when it registers. And so basically it's just saying, okay, I found a bunch of stars in here. They all seem to match. And then we can play these back like a movie. And I remembered why the other set didn't work. Notice I've got 3 points. One of the images I had to throw out because it was throwing things off. Anyway, okay. So we zoom in and we look for an asteroid. Gee, I think we found one right off. It's pretty easy. That little moving dot, that's our asteroid. So I'm going to stop this. And I'm going to, when I click on the asteroid, Astrometrica brings up this little subchart and says, okay, does this look well-centered? I explained this last time a little bit, so sorry if it's a repeat for those who are repeat customers. So that the red line is how bright it should be, and this is a function of position. So if you like cut a line through the middle of this object, it should look like that red line, and then the white dots are what we actually are seeing in this image. And you notice the white dots match that red line very nicely. So it's well centered. And now we're going to ask Astrometrica if it happens to know what this object is. And it says, the closest thing my closest guess is this asteroid right here. But that's 2.4 arc seconds or 2.4 arc minutes off in right ascension, another 1.1 off in declination. Magnitude is a pretty good match, actually. 19.8 versus 19.6. That's how bright it is. So there should be an object about this bright somewhere in the image, but it probably shouldn't be here. I'm going to go ahead and guess that that might be it, but this is something that we would want to double check. Okay, so we go through and we mark that in all 4 images by clicking on it, quickly scanning that, giving it the name that that Astrometrica found for it. And we want to do that in all 4 images because we need those 4 data points. So there we go. Okay, now we've got to search the rest of the image. So we're just going to start in the upper left corner. And to be honest, this set of images I kind of think might be a known object because there were these 2 objects in the previous set of images, and the 2 objects were pretty close, but one was fairly close to a known object. Okay. So we're just going to go ahead and look for anything that is moving in here. And actually, why don't we go ahead and put the measurements we did of that object into Minor Planet Checker, save a little bit of time waiting for that. So I'm just going to copy one of these sets of measurements. This is the year, the month, the day, and this is like the time of day. And then these start to be the coordinates, like longitude and latitude in the sky. That's the brightness, and that's the telescope. K91 is the telescope on Las Cumbres Observatory that was used for the observations. All right. And if we have questions, please let me know. Anyone, or is everyone doing good? I hope everyone was going, yay, hi JD or something.
I hope so too.
All right. So yeah, this is the Maker Fair, isn't it?
That's right. That's right. The City of STEM and Makers Fair. I believe this is the first
All
time
right.
that we've attended this event, and hopefully I'll be there in person next time.
Oh, that'd be great. Yeah, I love makers. They're awesome. We have a makers group out here on Maui, and they always, every one of them has some sort of crazy thing that you just look at and go, well, what's the point of that? And well, I guess that really is kind of the point, just to be different, to have something fun. You know, it's the whole point is to have something fun, and I love that. But they also make very practical things. If something breaks and you need it fixed, makers are a good place to go talk to them, because sometimes around here it's hard to get replacements. I know that the Maui Science Center, we worked with the makers. They were making exhibits for us. They made some really cool exhibits for us. So that was kind of fun, kind of cool. Oh, by the way, I recognize, where do they go? Um, these 6 stars I actually recognize because I was having a hard time getting this to register last night and was using these to identify, to figure out where I was, because it was a unique little combination of stars. So we're just going to continue carefully looking. Yeah. So no questions yet?
I don't see any in the chat from my colleagues yet. So it could be that,
Okay.
just kind of walking by and watching. But yes, Lindsay, Anand, please post any questions or comments in the chat if they come up. Thank you.
Yes. Yeah, the astronomy a lot of the time is sort of a hurry up and wait thing. And for this part of the demonstration, the audience is in the waiting phase, because I honestly need to do this. I honestly need to get check these images for measurements. And that means scanning through a lot of the image that there might not be anything in here. Oh, here's one.
Oh, I see that one too.
Yeah, there we go. And so Astrometrica is not great for this, but it's a good start. It doesn't catch it every time. Okay, 0.2 arc minutes, 0.4 arc minutes, and magnitude is pretty good match. That's probably the target that it thinks it is. So that's a known asteroid. In fact, if Astrometrica knows about it, it's probably a pretty well-known asteroid.
JD, are all the bright objects that don't appear to be moving background stars?
Most of them. This one would be a galaxy. So the way you can tell is that this star, which isn't that much brighter. Okay, this star is about as bright as this object, right? There is a diffraction spike there, and 2 more there and there. So that means that this is a point source. It's so small that we're seeing no size on this object. Okay, and these spikes actually come from the structure that holds up the secondary mirror in the telescope. So this spike this way comes from a bar that goes this way. And then the fact that it's waves kind of puts the spike out perpendicular to the bar. But since this is a resolved object, we're actually seeing the size here. We see an extended object, and so the spikes from each individual point, they're blurred out enough that we don't see them. And hope that wasn't too much detail, but
It was
yeah.
perfect.
Okay, great. Yeah, that's right. These are makers. These are smart folks. Smart and creative folks. Yeah.
Is there a program that you use to, in addition to using your own eyes, to look for potentially moving objects in these different images, or is that not very reliable?
There is so Pan-STARRS has so much data that it is just not possible to get eyes on all of the data. And so they have a program called the Moving Object Processing System, MOPS. And so they let they like mop up the data, right? I love that acronym. And it does exactly that. The problem is people are still better. And MOPS is really good software. It actually detected Oumuamua, which I would bet that a person would have missed, to be honest.
Oh, wow, it detected Oumuamua.
Yeah, so the Oumuamua was first detected by a computer, and then Robert Weirk got up in the morning and saw the detections from Pan-STARRS and started going through them and looked at Oumuamua and was like, well, this ain't right. This is not normal, and this is just its huge velocity. It was moving way too fast to make sense. And so he kind of did some double checking, and sure enough, that's what the measurement said. And he realized, oh, this is an interstellar object. There's no doubt about it. It came from somewhere else. It ain't from around here.
Incredible.
Yeah.
So
And so,
that kind of program is useful, can be useful for helping with with these kinds of detections. Is that something that
mhm.
you use when you're doing follow-ups, or these follow-ups like
It could be. Let's see here. Tools. There is a known object overlay. Let's see here. Moving object detections. This is not as good as MOPS. It was, when this program was made, it was probably state of the art and the best. My understanding, though, is that people are still better than computers. Okay, so I just had it go through and it said no moving objects detected. We found 2. So there you have it.
okay.
Actually, let's do known object overlay and see what this says. And oh, the Minor Planet Center is back with the object. Okay, so if it was this one, I think it was that one. That is a known object. Let's see here. 0404, yeah, that would be this one. Okay, so this one, they're saying, yeah, this is most likely what that is. And this one here, that's most likely what it is. So we followed that one now. This one is the one that we were not sure about. And so this is the one we're really hoping to chase down. And I changed the name of that to ARMST-07. I actually have discovered an asteroid, is my understanding. Sadly, I don't know what the name of it is. I have to try and track that down. I did at one point. And I think Astrometrica might have actually frozen. Sometimes it does this. Okay, let's go in and look at the other set of data. I'm going to restart Astrometrica.
Is Astrometrica, I dropped a link in the chat in case my colleagues, want to keep it and share it with others who may be coming up to the booth. But is this is fairly straightforward for someone, without much experience to use, or are there kind of
Oh, there we
tutorials?
go. You can find tutorials online. It actually takes a little bit of time to get used to. Okay, so that object, it looks like it is compared to this one. Okay, so that I would say is most likely a match. It's just off a little bit. Where did the other one go? This one, that could be a match. But it's way off. So maybe what we do, let's see if our coordinate system was correct. I'm going to come down to the bottom right corner here, and I'm going to say, okay, give me the coordinates of this star. Just going to name it star 01. Go into the report here. No, that changed the configuration. Go into the report here, view, MPC report, and star 1. So I'm going to grab the coordinates, the right ascension and declination, and I'm going to drop that into Google Sky. Google Earth has a sky component. So if you've ever used Google Earth, you've got this wonderful tool that will show you the sky. Okay, so that star there is supposed to be, where did we go? Okay, so that star is that star a match with that star? Okay, okay, so there's this very bright star, check. Kind of goes this, check. Yeah, so this is the right star. It's well aligned. Typically, I would do that with both corners, but I'm not going to this time because we've already kind of also checked our match with by looking at some asteroids. I'm going to get this running while we're checking a couple more things on this set. I need a different configuration and hopefully this will fire up right. So yeah, we want to double check that, but since we've kind of already looked at things pretty well, we found some matches of okay, I'm going to come back to this in a moment. Since we've already kind of found some things that indicate maybe it's all right, I'm not going to worry too much about it. And let's go over to the Minor Planet Center, see what they say about this file, view MPC report. So this one is the first one we're really interested in. That's right here. They say, oh no, that's a pretty good measurement. That agrees with our orbital calculations. So it may be that Astrometrica's numbers are a little out of date. Let's also check this one, but I'm pretty confident that that's a well-known asteroid. So I'm going to go ahead and close these. File. I'm going to reset the files so that I don't get anything confusing. And hopefully I didn't make a mistake there, because I could see this being an unknown object in reality. And then that is pretty rare to happen. All right, and so we're going to try to align these. Yeah, so again, offset. It says, yeah, the offset is smaller than the precision we're going to give you. The magnitude 20.4 versus 20.2, that's actually a pretty good match. So I'm very happy with that. Let me see if I've got the right configuration. Okay, so yeah, the objects in those images were apparently known. And I think that this is what I used, the configuration I used that got this going, these images to register properly last night, but we'll see. Hope so, because I need to do the measurements still. Okay, we got the alignment, we got the registration. We're going to zoom in. And yeah, I always look towards the center of the field. That's for just a moment, because that's the most likely place for it to be. If you've got good measurement, if you're observing at the time of prediction, then basically that's where it's predicted to be, but then you've got an error where it could be the rest of the image. So don't always find it there. I didn't see anything. These images are a little weird. Let me see. How faint are we going? So we're only going to magnitude 19. That's actually a little bit of a concern, because if I recall correctly, the prediction for this is a bit fainter.
Yeah, 20.4 or 20.2.
Yeah, so if we see it in these images, then it's going to be a faint one. So we got to keep our eyes really open on this one. And that may actually be the answer, is maybe we didn't go faint enough. Who knows? Hopefully we did.
JD, this image seems to be doesn't have as much clarity as the previous images we were looking at. Is that just my perception?
Yeah. Well, I would say no, you are correct, because like I said, we were only going to maybe a little fainter than magnitude 20. And the other one, we had those objects and they were magnitude 20. Does that look real to you?
Right. Yeah, I can't tell if it's just a pixel being weird or not.
Yeah, exactly. Looks like it might be real. Let's see if it's known. But yeah, see, we're only getting to magnitude 19.6 on that. Um, if we can believe it, then that's probably a new object. But I am not entirely sure that it's all that believable. Well, so it does seem to be moving though, and it does seem to be moving sort of in a straight, constant line, right? So maybe, let's put it in the MP checker while we're looking at the rest of the images. Copy this, go ahead and paste here. But the fact that it's, wow, yeah, I honestly think that it's unlikely we're going to see the target we're looking for, which is unfortunate because at this point might be lost. We're going to go through the rest of them though, rest of these images, and see what we can find. And if anyone sees something that I miss, please let me know. Okay, let's see here. Yeah, see, they don't know anything about that. I don't think that's real. Yeah, let's see here. Where are we at? Well, there's something. Let's see what this is called. Okay, astrometrics, not sure about it. I'm going to guess that that's it, though. Is
Oh,
that's
okay. I
this?
see it now.
Yeah, this is an asteroid we've seen before, and so it might very well be what we're looking for. So I'm going to go ahead and put that in. Except I might want the whole observation. That would probably help. Do MPC report, grab a line, copy. Okay, so there's that. Okay, I went down, then I'm going up in my search pattern. I'm coming back down. I'm going to go a little faster than I normally would here because I want to program in some more observations with you guys.
Sounds great.
Okay, yeah, the Minor Planet Center says yes, that is indeed that object that we thought it was. So I'm content that that one's resolved. And it's going to be a long shot to catch it because this is a few days ago, and I didn't have a very long stretch of observations, but if I could catch it, it'd be very exciting.
How long did
Yeah.
you program the previous observations for a few days ago?
Okay, so the exposure time
Yes,
or
the exposure
yeah,
time.
so the exposure time, I think it was about 180 seconds. So
Okay, that's what I thought.
yeah. Um, yeah, but what I'm concerned about is, if something's moving in a straight line and you've got some variation in the error in some measurement error, and you only have 2 points close in time like this, by the time it gets over to the other side of the screen, you could be losing any hope of recapturing it. Down, up, down, up, yeah. And so that's kind of what I'm worried about. And especially when it looks like maybe that one object tracks back to a known object, because this guy keeps showing up at about the right place and right time. Let's go ahead and now that I remember what the trick was. Okay, I just need to know which one of these to throw out. So if we blink them,
Can you explain
it'll
the comparator?
the comparator. Okay, so these are the images that were the first follow-up set on the unknown. And all I'm doing is telling Astrometrica, play these like a movie, even if you don't know where they are. And it's saying, okay, these three are over here, and this one's over here. So obviously, Astrometrica is having trouble with this image. So I'm going to close that image. And now I'm going to try to register this, and these hopefully will work. In the meantime, let's go and ask Minor Planet Center to create new object ephemerides for this object, that the fainter object that was detected. Where is my minimize view? Here we go. Cancel. It's 88 that it did not like, if I recall correctly. So, okay. And so I'm just going to use these three measurements to predict some positions. And let's go with W85. That's in Chile. That's the best site on the Las Cumbres network. Well, actually, I've heard argument that maybe Haleakala is better, but it's the best site for the 1 meters. And so I give them the observatory code, tell them to give it to me in hours, please. And then it gives me predictions of the time and location. This would be 21st magnitude. It's moving a little quick to get to 21st magnitude, so that might be a challenge. So we definitely want that good site. And I'm going to go ahead and object altitude. So we're going to go right here, copy that. And we'll probably try to get it a little earlier in the morning or a little earlier in the evening. And this was '07. Oh, cool. We're gonna run over. Is that all right?
Absolutely. Let's do it.
Okay, we'll run over a few minutes. Hopefully somebody's enjoying this other than just the two of us, but hey, it's worth it if it's just us, right?
Absolutely. And it'll be posted on our YouTube channel for others to check out later on as well.
Oh, great. That's wonderful. Yeah, you guys, you have a whole bunch of archives. Oh, I gotta brag, everyone. This is Brighton. He is a student here on Maui. He's a high school student. He wrote a book on astronomy using images from NASA and Las Cumbres Observatories. And so I'm really proud. It's a children's book. The evaluations I've heard is that it's good for about third graders is the target audience. So if you want to go to Las Cumbres Observatory, you can find that, including a link where to buy it. Sorry, I just turned into a commercial, I know. I hope nobody minds. But I'm just so proud of him. Just really proud of him.
That really is fantastic. Thank you for sharing it with us.
Yeah. Oh, good. Okay, so we're going to go in. We're going to program observations for this. And it's 21st magnitude. So we really kind of need 3 minutes of integration time, which you can't get when it's moving that quick. If you put in 3 minutes of integration time, it's going to be streaked, and that doesn't help. Okay, so we're going to go. I'm confident we can go 120 seconds without streaking, but 180, which is what we really want, is going to be too long. So, okay, this is the form. I guess I should explain this. It just basically says, hey, what's the name of this set of observations? I'm going to call it Armstrong 7 because this is, I've restarted over, by the way, a number of times. There are several asteroids that I was the first one to have reported seeing it, but nobody else saw it that year, and so I did not get credit for discovering it. Kind of sad about that, but those are the rules. All right. But this is just the account that it goes on, and acceptability threshold is, if you don't get 90% of the observations, try again, and you have to stop, then try again. Configuration repeats, do this once. Optimization type, just get it done. Mode, mosaic, you can actually make a mosaic of images. We're actually going to come back and turn dither on. We've selected the 1 meter Sinestro. So this is a 1 meter diameter telescope with a Sinestro camera, which is Las Cumbres' in-house camera. The name of the object is this, which it's a placeholder in this case. It's an unknown object. And these are the predicted coordinates that we just got from the Minor Planet Center. So right ascension, declination, and we want to put this on Siding Springs, or not Siding Springs, Cerro Tololo. That's Chile. South Africa is a good location, but we may need the best we can get. So I'm going to I don't know how cheaty this is, but I'm going to basically narrow down the window so that it forces this to be from that particular site.
It's really
Okay.
amazing how much control you have here over how the observations are taken, like, and where they happen.
Yeah, yeah. In fact, I kind of wonder sometimes if it's a little bit to Las Cumbres' dismay, because they really want everyone to think about the network as a single observatory, not a collection of telescopes. And they want everyone to, use all the telescopes equally, but then they will admit that yes, some sites are better. So they don't want everyone using just the best telescopes, which is understandable. But yeah, they give us all the flexibility that we really need. If I really did have a science justification to choose a specific telescope, it is possible to do that. And I've done that for observing parallax. So if you look with two telescopes, you can actually measure the distance to the object if it's within the solar system. It's the same way we measure the distances to stars by measuring in, taking two observations 6 months apart. Okay, where was I at? Oh yeah, dither. Okay, so in order to do this, we one of the things is sometimes there are little grungies that are left over from the calibration. And sometimes those grungies strangely move in a straight line, and so it's easy to mistake them for an asteroid when they do that. It's not all the time, it's not even usually, but it's some of the time. In order to get rid of that, what I'm going to do is I'm going to dither the observations. Okay, so what it does when it dithers is it starts here, moves up a little bit, moves to the left a little bit, and then moves down a little bit for the fourth observation. Okay, except I want to be doing 8 observations so that I can add, or 8 images, so I can add 2 of them together, 4 times, and that'll get me my extra integration time that I think that I need. So I'm just going to go ahead and do number of rows 3, number of columns 3, generate dither. And yeah, so that'll kind of do a snaky pattern. And I'm going to tell, okay, it's going to take half an hour. It's a long shot that we get this, but that's okay. And then we're going to come back here and I was going to show you, if we have time to do so, I'm going to show you, yeah. Okay, so here's one of the objects. And do you see this pattern of spots that is all, it moves to the left and then down to the left?
Yes.
Like right here? Okay. Yeah, if that's coming through on the screens, then then we're getting nice clear images. That's what I'm talking about some artifacts or some things that are not being cleared up by the flat fielded bias dark. Sometimes their flat fields get a little older, especially for the W-band filter, because not a lot of people use it. And so apparently what they're telling me is, JD, you didn't use this telescope enough. We're not taking your flats anymore.
Oh
Um,
no.
yeah, so the two objects are this one right here. Okay, and you can see that it's stretched out a little bit. That's that motion streaking or motion blur that I'm talking about. And you can see there's this star here. It's involved with the star. It kind of does not seem to think that that's a very good match, but I'm going to say go ahead and accept it, because at this point, I've kind of decided that yes, this is it. Let's do known object overlay. That would be a good idea. And so
And for
this
the
is
upcoming
basically,
observations that you,
go ahead.
oh, sorry. I was just asking, when did you program the upcoming observations for? Is that for this evening or tomorrow evening?
Yeah, it'll be this evening in Chile. So in a few hours. Let's see here. I centered it around 5 Universal Time for tomorrow. Hawaii is Universal Time -10. I think that California, California is where our event is.
Yes.
Okay, so California, I believe, is UT -7 hours. So 3 hours off from Hawaii, is that right?
Yes, absolutely. You got it.
Okay, good. Yeah. Because California does that weird daylight savings thing that always confuses me. Um, so basically, UT -7, that would be 22 today, 2200 hours today. So that's 10 p.m., right?
Yes. Okay. Exciting.
Okay. Yeah, I know. It's kind of, I've got to admit, I think it's a long shot. So this target right here, this is the target, this is where Astrometrica believes this one should be. I don't see anything that I would associate with. Do you see this little object over here?
Just barely.
Just barely. Okay, so your screen is about as clear as mine because it's just barely as well. That's this object, this what I'm calling ARMST7 that we're trying to track down. I think that this was the original unknown object that I detected. Okay, but then there's this that showed up in the follow-up images, because the follow-up images, even though it's got these artifacts all over, they're actually clearer and fainter. We're going down to magnitude 21 on our detections. And let's see what the integration time was. All right. And so I'm gonna. This is instead of Astrometrica. This is SAO Image DS9. This is a free program. Anyone can grab it from the Harvard Smithsonian. It's great for showing fits images, and you can do a little bit of, scaling and other thing and some measurements. I'm just using this to jump in and get to this header information because I want to confirm. Yes, yeah, 180 seconds to get me to magnitude 21. That's about as far as I would expect to go on a good night. So, and this is streaked, so that would make it a little harder. So these are pretty good images, in spite of the fact that we've got that grunge floating around. And so you commented on those other images that you said that they didn't look as good to you. Well, that's a good eye. I did not spot that by my eye, but you apparently did. So good on you. Yeah. All
Yay.
right. Well, I think there's a chance that, okay, so it looks to me, here's the summary. We advertise this as, hey, let's go chase this object that is that might be unknown. Well, we chased that object and we decided that, oh, actually, yeah, no, we think we know what this is. This is it. But wait, what's this? And so we're off on another chase of an unknown asteroid. This one is a little bit long shotty because I don't know that we're going to recover it. The uncertainty in the positions are just too high. After 3 days, I think it's going to be a little long shot. So hopefully Pan-STARRS, who has a couple of times come in with observations of my targets 8 hours before me, hopefully Pan-STARRS will help us out with this one. But we love Pan-STARRS because they're guardians of the Earth.